Assignment number 13. Calculate the amount of nitrogen that will dissolve in 9 liters of water. If you convert 9 liters of water into moles, I'm telling you in short, 9 liters of water will be 500 moles of water. When a gas is bubbled through it at a pressure of 1.6 bar, calculate Henry's law constant is given. So Pg is equal to KH. KH is 40 kilobars bar m bar into mole fraction of the gas. Mole fraction of the gas will be number of moles of nitrogen divided by number of moles of nitrogen plus water. I told you if you convert into moles, it will be 500 moles of water. Neglect in the denominator and calculate number of moles of nitrogen will be 0.02 mole. 0.02 mole means multiplied by molecular weight, so many grams of nitrogen will dissolve. Second, calculate molarity of the solution which exerts an osmotic pressure of 2.4 atmosphere and 19.3 degrees centigrade. See, I is equal to I into MRT. Molarity we have to calculate. R is 0.0821. Temperature 19.3 will be 292.3 Kelvin. Molarity will be the answer. Next, calculate molarity of a 20% aqueous solution of nitric acid, density 1.26 gram per cc. Say solution is 100 grams. It contains 20% nitric acid. So 20 grams will be HNO3, remaining will be water. And volume will be 100 divided by density. Density is 1.26. So many cc. This is the volume. Now, we have to calculate molarity. Molarity will be weight of solute 20 divided by molecular weight of nitric acid is 63 into 1000 divided by this is the volume of solution. This will be molarity. Numerical number 4. In a solution of ethanol and methanol, mole fraction of ethanol is 0.4. Calculate mass percent of methanol in the solution. Say number of moles of ethanol plus number of moles of methanol is 1. Although you can assume 1, 10, 20, 100 is your choice, or you can assume X, but assuming 1 will be easy for you. Therefore, number of moles of ethanol will be 0.4. Now, why did I write 0.4? Because we are given mole fraction of ethanol is equal to number of moles of ethanol divided by total. I have assumed total number of moles equal to 1. Therefore, mole fraction of ethanol is this expression. Number of moles of ethanol will be 1. And number of moles of methanol will be 1 minus 0.4, 0.6. Now, weight of ethanol will be number of moles into molecular weight. This will come out to 18.4 grams. Weight of methanol will be 0.6 into molecular weight, 19.6 grams. Total will be 19.2 grams. This will be 37.6 grams is the total mass of the solution. Now, we have to calculate percentage of methanol in the solution, which will be 19.2 divided by total solution 37.6 into 100. This will be the percentage. Next, numeric number 5. Calculate the volume of 26.5% aqueous solution of sodium carbonate. Density of the solution is given, which should be mixed with 400 cc of 1.2 molar solution of sodium carbonate to prepare 560 cc of 2.4 molar solution. We know the molarity and volume of one solution. molarity of the other solution will calculate, and the volume will calculate later. These two will be mixed together, and finally we have to prepare a solution which will be 560 milliliters and 2.4 molar. Say solution is equal to 100 grams, 26.5%. So many grams will be sodium carbonate, and remaining will be water. That's not required. Volume will be 100 divided by density. Density is 1.2. So molarity of the solution will be weight divided by molecular weight into 1000 divided by this is the volume. When you calculate this, molarity will come out to 3. Now I'll use M1 V1 plus M2 V2 is equal to M final V final. This is M1 into volume. I have to calculate. Second solution, molarity is 1.2, volume is 400 cc, is equal to final molarity 2.4, final volume 560. We can calculate the volume of this solution required. Next numerical is a very, very important numerical. Try to understand it and write each and everything. First, let me write the equation. 2 lead ions aqueous plus 3 chromium solid gives 2 lead solid plus 3 chromium ions aqueous. Now I'll read this numerical for you and tell you what is given and what we have to calculate. 10.6 grams of chromium, 10.16 gram of chromium is added to 200 cc of aqueous solution of lead sulfate. 200 cc of this solution, leading to complete precipitation of lead ions as solid lead. So when these are mixed, all lead ions in the solution, they are totally converted into lead solid. It means this is not left and this lead solid is formed. Now, after filtration, 30.84 grams of solid was recovered. See, after the reaction, some solid chromium will be left unreacted and some solid lead is formed. This solid left and this solid formed is 30.84 grams. On the basis of this data, we have to calculate molarity of this solution. This is given. Now I'm starting how to solve it. Say number of moles of chromium used is equal to X chromium. Therefore, weight of chromium used will be atomic weight into this. Atomic weight is 52. So 52 X grams of chromium will be used. Weight of chromium left. We started with 10.16 minus 52.52x. So many grams of chromium is still left. Now, look at the stoichiometry. This is 2, right? This is 3 and this is 2. When 3 moles of chromium are consumed, 2 moles of lead are produced, right? And if X mole of chromium is used, how many moles of lead will be produced? The number of moles of lead produced will be 3 by 2, 2 by 3 into X, right? Chromium used is X. 3 gives 2, X will give how much? I can say 2x by 3 moles. Weight of lead produced will be So many moles multiplied by atomic weight of lead. So 2x by 3 into atomic weight is given 207. Let me tell you how much it will come out to. Something wrong with the equation. This is 3, this is 2, this is 3, and this is 2. Equation, please. It means this produce will be 3 by 2. 3 by 2. Into atomic weight, this will come out to 310.5x. So many grams of lead is produced, so much of chromium is left. This plus this is 30.84. So 10.16 minus 52x plus 310.5x is equal to 30.84. Calculate the value of x. This will come out to 0.8, 0.8 or 0.08, 0.08. It means x is 0.8 means number of moles of chromium used will be 0.08. Now again look at the stoichiometry. 2 moles of chromium consumed will, if 2 moles of chromium are consumed, then lead ions consumed will be 1.5 times more, that is 3 moles. So number of moles of lead ions consumed will be 3 by 2 times 0.08, 0.12 mole. It means this solution contains 0.12 mole of lead sulfate. Now final answer, molarity of this solution will be number of moles of lead ions means lead sulfate into 1000 divided by volume of solution. This will be the final molarity. Initially, we wrote the wrong equation. Stoichiometry was wrong. Otherwise, we would have calculated early. Next, number 7. Vapor pressure solution. Now, in this case, before I start, there's some error in the data given. Number 1, boiling point of acetone is not given. Boiling point of acetone is 56 degrees centigrade. And final answer will be 57.1 degrees centigrade, right? BP of acetone 56. Final answer will be 57.1. Let's see. Vapor pressure solution of X in acetone is 560 millimeters at 40 degrees centigrade. Calculate its boiling point. Kb is so and so, and vapor pressure of acetone at 40 degrees centigrade is 580. So P naught minus PS 560 divided by P naught is equal to mole fraction of solute. So mole fraction of solute will come out to 1 by 29. Say number of moles of solute plus number of moles of solvent. Solvent is acetone is 1. Therefore, number of moles of solute will be 1 by 29. And number of moles of solvent, that is number of moles of acetone, will be 1 minus 1 by 29, 28 by 29. Now from this, we can calculate, rest we'll use in elevation boiling point. Delta TB is equal to I is 1 because there is no idea whether there's association or dissociation. Kb is 1.767 into molality. Molality, number of moles 1 by 29 into 1000 divided by weight of solvent. Weight of solvent will be number of moles of solvent into molecular weight of solvent. Molecular weight of acetone 58. So this will be 28 divided by 29 into 58. When you calculate, elevation will come out to 1.1. So boiling point of solution would be 56.56 plus 1.1, 57.1 degrees centigrade. In next two numericals, both are similar. Next two numericals, both are similar. There's no calculation required. Let me explain. See, numerical number 8. 39.7 grams of urea, sugar, and glucose are separately dissolved in 200 grams of water. These are three solutions. In all the three, weight of solute is same, weight of solvent is same, solvent is also same, means Kb is also same. Only molecular weight of solute is different. I is also same. So I can say inversely proportional to molecular weight. So molecular weight is high, means elevation or depression will be low, and rest you can answer. Same is the case in the next numerical, so I'm skipping that one. Coming to theoretical question. Ionic solute AB2. AB2 will give 3 ions because it is mentioned ionic. Ionizes completely in aqueous solution, predict its molecular weight, determined on the basis of colligative property. So in this case, due to dissociation, molecular weight will come out to 1/3, that is 70 is the answer. Second question. What is the value of Van 't Hoff factor for the following solutes dissolved in water? At the end, we are given A and B are strong electrolytes, means they will completely ionize. C is a weak electrolyte. Now, A part, this compound will form 4 ions, therefore I is 4. B, barium chloride, this will give 3 ions, therefore value of I is 3. C part, third, acetic acid. It's mentioned this is a weak electrolyte. It means value of I is more than 1 but less than 2. Right? Because it will give 2 ions, but value of I will be more than 1, less than 2. Third question. Why does association of solute take place in an organic solvent like benzene but not in water? See, the reason is water is a polar solvent, and polar solvent helps in ionization of the solute. On the other hand, organic solvents are non-polar and they help in association of solute molecules by the formation of hydrogen bonding wherever possible, right? But in any case, ionization will not be helped by organic solvents. Fourth, what is the effect of dissociation, association on colligative property and molecular weight? Like if I take a dissociation first, colligative property will increase, molecular weight will decrease. In case of association, it is opposite. Colligative property will decrease, molecular weight which we calculate that will increase. Fifth, what is common in all colligative properties? If you want, you can write. They all depend on effective number of solute particles. Second common is independent of nature of solute. Third, inversely proportional to molecular weight of solute. I think this is sufficient. And one thing more you can write, all used to calculate molecular weight of the solute. These are 4 common points about colligative properties. Last question. Under what conditions will a colligative property give accurate molecular weight of solute? One is solute should neither associate nor dissociate. Very important. Number 2, solution should be very dilute. Third condition, temperature should neither be very high nor very low. And fourth condition, in case we are performing the experiment on osmotic pressure, then SPM should be strong. Semi-permeable membrane should not rupture during the experiment. So with that, we finish all the assignments on solutions. Now you should start getting prepared for tests on solution. One will be MCQ based test and the other will be subjective test. I'll write dates for these tests tomorrow. Right.